We've created a new game object, the top or head of our missile launcher, that will respond to input and swivel around. At least, it will when we program it to. That's the code we're going to write right now. Like in the 2D game tutorial, we have to decide how we want to map actions on the controller or keyboard to game changes. We're going to want to swivel the head of the launcher in two axes, left and right, and up and down. Sounds like a great candidate for a thumbstick on the Xbox 360 controller. Let's use the left one. And we can use the up, down, left, and right keys on the keyboard for the same purpose. Code that manages input and changes in game object state, such as changing position, rotation, and more, should be done in the update method. Go to it now. Inside the update method, you'll see some code already written for you that exits the game if the back button is pressed on the Xbox 360 controller. This is good code to keep in your game, so go just below it and add a new line. Then add the following code. Gamepad state, lowercase gamepad state, equals gamepad.getState, playerindex.1. As in the 2D game tutorial, we get the state of the controller using the gamepad state class, and that tells us the position of the sticks and buttons. We'll use that to determine if the player is pressing the thumbstick in a particular direction. Add the following code. Missile launcher head .rotation.y minus equals gamepad state .thumbsticks .left.x multiplied by 0.1 f. Missile launcher head .rotation.x plus equals gamepad state .thumbsticks .left.y multiplied by 0.1 f. Here, we're changing the rotation value of the missile launcher head by the input to the left thumbstick's X and Y axes, scaled down by a significant amount. The controller thumbsticks are very sensitive. Now, taking a look at this code, you may have some very immediate questions. First, why do we use the X-axis of the controller to change the Y-axis of rotation, and vice versa? Why not X for X and Y for Y? This is where an understanding of pitch, yaw, and roll, known as Euler angles, comes in. When we say we want to rotate the missile launcher head up or down, we're saying we want to change its pitch. Pitch as a rotation angle is around the X-axis. When we want to rotate an object left or right, that's called yaw. Yaw is a rotation around the Y-axis. To visualize this, take a look at the detailed text for this step. It contains a definition for Euler angles and a diagram to help you understand how they work. Because you're rotating around the axis, you don't move in the direction of it, you rotate around it. So while X is side-to-side translation, it is up and down rotation. The axis is used as a reference, differently between translation and rotation. Just remember, pitch, yaw, roll, X, Y, Z. The second question is, why do we subtract the yaw rotation but add the pitch rotation? This has to do with the coordinate system used in XNA Game Studio. A similar backwardness happened in the 2D game tutorial. Because of the right-handedness of the coordinate system, rotations around the y-axis are in the clockwise direction instead of counterclockwise. This means negating some values. Let's make sure keyboard input is supported. Below the code you just wrote, add the following. Pound if, exclamation mark, Xbox. Keyboard state, lowercase keyboard state, equals keyboard.getState. If keyboard state dot is key down dot left. Missile launcher head dot rotation dot y plus equals 0.05 f. if keyboard state dot is key down, keys dot right, missile launcher head dot rotation dot y minus equals 0.05 F. If keyboard state dot is key down, keys dot up, missile launcher head dot rotation dot x plus equals 0.05 F. If keyboard state dot is key down, keys dot down, missile launcher head dot rotation dot x minus equals 0.05 F. Pound and if. This is a lot of code, but it's fairly straightforward. We check the keyboard state to see if a particular arrow key is down. If it is, we move the rotation in the corresponding direction. The code is bracketed by the pound preprocessor command if Xbox to make sure this code only runs on a Windows project. Now we need to make sure we restrict the angle that the player can rotate their missile launcher. This keeps the missile launcher aimed in the general area where the enemy ships will be coming from, so it keeps the player on track. Below the pound and if, add a new line and the following code. Missile launcher head dot rotation dot y equals math helper dot clamp missile launcher head dot rotation dot y negative math helper pi over 4 math helper pi over 4. This first math helper dot clamp method clamps the yaw, remember, y component, between two radian values, negative pi over 4 and positive pi over 4. In degrees, that's negative 45 degrees and positive 45 degrees. If you think of 0 degrees as being straight away from the screen, then the launcher head can swing no further than 45 degrees to either side of that line with this clamp call. Add this second clamp call for the pitch. Missile launcher head dot rotation dot x equals math helper dot clamp missile launcher head dot rotation dot x 0 math helper dot pi over 4. This clamp call clamps down the pitch, x component, of the missile launcher head to between 0 and positive pi over 4. Again, that's 45 degrees. If 0 is parallel with the ground, then the missile launcher can rotate no higher up than 45 degrees and no lower than back down parallel with the ground. We're set and just about ready to take input and try it out. We need to make sure we do one last thing. Draw the launcher head.